Hello, everyone. Good afternoon. So let's start. My name is Adma Gamakromo, and I'm a second year PhD student in. Can you hear me? Suppose.
Yeah.
No, but suppose here from here.
Yes.
Okay, thank you. So I'm a second year PhD student in education at Warner School, UFR, and with a focus on the ethical and philosophical implications of leverage VR and AI technologies for learning and teaching. I'd like to say thank you for joining us for the Voice of XR. And also, I would like to say thank you to Mary and McVernack Studio X Speaker Series. This series is made possible by Kathy McMurray and National Science Foundation as part of the interdisciplinary. Oh, something. Is every? Hello? Okay. I don't know what.
This meeting is being recorded. The account holder can watch this recording if it's stored in the cloud. Participants granted permission to record and share. This meeting is being recorded. The account holder can watch this recording if it's stored in the cloud. Participants granted permission to record and share. Leave meeting button.
What is that?
Slide 1. XR access. This meeting is being recorded. Leave meeting button. Got it button. XR access disabled.
Is it a closed
Wow.
caption?
AI revolution. Not sure. I'm not. Should I?
Option.
Yeah, should I?
Just a second.
Yeah, let's wait a little bit.
Stay muted. Disabled. The host would like you to unmute. Disabled. Connect.
Hello. Hello.
Hello.
Oh, okay,
Hello.
can you hear me now? Sorry, I didn't realize I was muted.
Yes,
Yeah.
yes, we can hear you.
We try to fix first, like the technical problem. So I think now we can continue.
Yeah, I think we're okay.
Okay, so let's continue. So this series is made possible by Kathy McMurray and the National Science Foundation as a part of the interdisciplinary graduated training in science, technology, and applications of augmented and virtual reality at the University of Rochester. Now, I would like to introduce the speaker for today's event. So I hope I can pronounce the professor's name correctly. If not, please help me. So it's Shiri Azenkot.
Yep, that's right.
That's right?
Mhm.
Okay. So she is an associate professor of information science at the Cornell Tech who does not like bloated bios. So here's the basic. She researches accessibility with a focus on emerging platforms like augmented and virtual reality. She publishes at the typical top venues for accessibility and human-computer interaction and has received the typical awards for someone at this stage in her career. She directs the XR Access Initiative. For more information, talk to her at the 2024 XR Access Symposium.
Yeah, oh, okay, the 2024 XR Access Symposium, yes.
Yes. So in this talk, she will present XR Access, which she co-founded to promote XR accessibility, research, and practice. For the last 5 years, XR Access has been bringing together practitioners, researchers, and advocates in conferences and seminars, developing research and supporting students in XR accessibility. She will present a case of XR accessibility research and outline ways in which you too can join this movement. So I would like to give the voice to her. But before that, if you have any question, please feel free to put in the chat. Then after her talk, we can have Q&A section. And also, I'd like to say that we're going to record this session, and it will be available later on in the Studio X website. Thank you, Professor Shiri.
Yeah. Hi, everyone. I just want to check on a few things before I start. Can you see me zoom in right now? Is anything happening?
Not that I can tell.
Okay, good. And then my camera is blocked, so let me unblock it for you. Oh, oops, sorry. And let me silence my phone.
Zoom floating video window. Slide 1. XR access making augmented and virtual reality accessible to people with disabilities. Disabled.
Okay.
Zoom floating video window. More. Zoom share toolbar window. Annotate button. Slide 1. XR access making augmented and virtual reality accessible to people with disabilities. Time remaining. Zoom share toolbar window. Start video. Zoom share toolbar window. Start video. Zoom share toolbar window. Start video button. Zoom share toolbar window. Start video button. Stop video button.
Okay, hello.
Participant has enabled closed. Disabled. Zoom floating video window.
So I'm turning on my video just to say hi, and I'll turn it on for Q&A, but during the talk, if that's okay, I'll keep it off so you don't have to see me
Slide 1.
staring at my screen.
Stop video button. Video stop. Stop video button.
So one more question. So we
Zoom share
have
toolbar window.
until
Slide 1. XR access making augmented and virtual
3:15,
reality. Disabled.
right?
Command. Disabled.
Yes? Timing, do we have until 3:15?
Slide 1. XR access making disabled.
Yeah, sorry, we didn't realize we were muted. Yes, until 3:15, but we're also getting some feedback from voice recognition software. Are you using that on your end? Because it's we're hearing that on our end.
Oh, it's probably because it's transferring audio. Because I want to show some videos. Let's see.
We're hearing something that sounds
Slide
like
1.
a
XR access making
very
augmented and virtual reality accessible to
graphic
disabilities. Disabled.
screen
Yes,
reader.
you just heard that, right?
Yep.
Okay. Yeah, that's because I turned on the audio sound because I'm going to be showing some videos. So it's not, once I get started, it's not going to be very frequent. So yeah, so you can just ignore it. Okay. So with that, let's go ahead and get started. So yeah, as said in the introduction, I'm sorry, I didn't catch your name. The person who gave the introduction. I will be speaking about XR Access today. This is the same talk that I gave as the keynote for IEEE VR just last month. So you guys get to hear it here as well. So you guys all probably know already that XR, and by that I mean augmented and virtual reality technologies, are on the cusp of becoming mainstream. These technologies have actually been around for quite a few decades, but they're finally becoming more affordable, more available to the consumers, and they're slowly starting to enter different domains. So we're seeing more interest in using VR in education and in healthcare, and using augmented reality tools for accessibility, and also for many other scenarios for remote work and tutorials, all kinds of different domains, which I'm sure you've been hearing about in this lecture series. And my personal interest in this area in augmented and virtual reality started when I was finishing up my PhD back in 2014, right around the time when Google Glass came out. So some of you probably remember that time. So there was a whole lot of hype and also quite a bit of consternation, but we'll put that aside for now. But there was a whole lot of hype and excitement about Google Glass and about the sorts of things that Google Glass can do. So just to refresh everyone's memories, and maybe for those of you who don't quite remember what Google Glass could do, this was basically a head-mounted display. So it was a set of glasses that you would wear. They were a little large, a little uncomfortable, and they had this little display that sat kind of at I think it was the left side. So the bottom left side of your field of vision on your left eye. And it was essentially a heads-up display. So it could display all kinds of information, like it could show whatever notifications you were getting on your phone. I think the idea was that it might be able to show you like direction information, routing instructions, and so on and so forth. And I was excited about this because I saw a huge potential for this kind of technology to be used for accessibility purposes. And specifically to support people with visual impairments. So people who had some kind of visual disability or vision loss, but still had some amount of vision and could benefit from some visual enhancement that could be projected in their field of view by a similar device. So I began my career at Cornell Tech in 2014, and right away I embarked on a set of projects that aimed to do exactly that. So my students at the time and we developed several prototypes that were augmented reality prototypes, and they helped people with low vision solve problems in their daily life. And they did this by using computer vision and then deploying or visualizations, overlaying visualizations on the user's field of view. Here's an example of one project. We call this project QC. And in this project, we were looking to solve the problem of visual search. So very generally speaking, the problem of visual search is finding a known target among a set of distractors. And so we actually do visual search all the time. This is a fundamental visual task. It's hard-coded into your visual system. And even when you're walking around, you're actually constantly doing a visual search for obstacles, right? So as you're walking, you're not probably aware of this, but if there is an obstacle in your way, it'll pop out at you. And you'll know to avert it. And this is all happening at kind of like a subconscious level. And there are slightly more conscious examples of visual search. Let's say you're looking around for an exit, right? So you're in a room, you're looking around for the door, so you can glance around and the door will pop out at you. Or the example that we worked with was you're at a grocery store, you're at the particular aisle that has all of the pain relief medications, and you are looking for a specific type of Tylenol product. And so you glance around and you're looking for Tylenol extra strength, and so it'll kind of pop out at you. You'll be able to pick it out among a set of distractors without having to stop and read every single product. So that's what the visual system is designed to do. But for people with low vision who have some kind of visual disability, this is actually an incredibly difficult task. And what they end up doing is having to go, once they find the right aisle in the store, they have to pick up every item individually and closely examine it to see, is this the item that I want? So it's an extremely laborious task. And we did actually some research and found that this challenge was not only extremely difficult, but also there were no existing tools that addressed this particular task. So all of the existing tools for low vision helped people see details like magnifiers of various kinds and people using their phones to take photos of things. But seeing details, again, that's a completely different type of visual task than visual search. So here we were, there was no existing solutions to supporting a visual search task. We wanted to help people with low vision do complete daily tasks. So we designed an augmented reality system that helps people complete this visual search task in the context of finding a product at the grocery store. So we designed a prototype. It was actually on a video see-through head-mounted display. And it used computer vision to find a target product, and then it overlaid cues that were specifically designed for low vision to help the product stick out. So to support this visual search task and to help the low vision user find the product more easily. You can see an example of these visual cues. So we designed them specifically to consider different types of visual conditions and also to leverage some natural features that grab attention. So for example, one of the cues, so there was a set of cues and you can see a couple here. So one of the cues turned the background to black and white and kept the target product in color. Another cue overlaid 8 lines around the periphery of the display that converged at the product. And we designed a few more. And we did a study and we found that this was very helpful. So this was one project QC, but we actually have done several others. And you can check out the papers under my Google Scholar. These are all published. So we looked at AR visualizations to support stair navigation and wayfinding and a few other tasks as well. But throughout all these years, since 2014, all the way to today, I myself, so I have low vision, I haven't been able to use the augmented and virtual reality devices that we've been programming with. And we've been playing around with a variety of products, and none of them have been accessible. So my students have to do the development themselves. We talk about things very closely, but ultimately they need to build some kind of accessible prototype, launch it on the device, hand the device over to me, and then I can comment on it. And my background is in computer science, so I was always building things. I like building things. I want to be able to program in VR. So this, this is a real problem, and it's not just for me. According to the U.S. Census Bureau, 1 out of every 4 people reports having some kind of disability in the United States. So low vision is a relatively low incidence disability, but there are many other kinds of disabilities that likely affect the way people interact with virtual and augmented reality technologies, whether it's hearing or motor disabilities that impact the way people use their hands, or even mobility disabilities that impact the way people move around, because now we're talking about 3D computing in space, not just sitting at a screen. And a few years back, having this in mind, something very unusual happened. This was the winter of 2019. So I think it was January 2019 to be exact. And like I said, something very unusual happened. I realized I had some extra money that my collaborators and we didn't know what to do with. So we had this huge grant, and there was some extra money set aside for a workshop. And we didn't have a particular topic for this workshop. So I suggested, why don't we do a workshop on making augmented and virtual reality accessible? And the idea here was that we should look at how to make the mainstream devices accessible, not look at how these devices could be used as assistive technologies. So the example I showed you with QC, leveraging these devices as tools for people with low vision, there were already some people working on that sort of thing, on how we can use augmented and virtual reality devices to support people with disabilities. But it seemed like nobody was really considering how the mainstream devices, the mainstream applications, whatever games, whatever educational applications were being designed for everyone, how to make those also accessible to people with disabilities so they can fully participate. So that led to the XR Access Symposium. The very first one in 2019 was held in the summer, and we reached our full capacity. So it was 120 people, and we brought together academics, researchers, students, industry leaders, so practitioners from all of the companies you'd expect, and also some advocates, disability and accessibility advocates, and some folks from nonprofit organizations that were interested in VR. we brought them together and we listened to some talks, we had some breakouts, and we established an agenda for what needs to be done to move forward towards making augmented and virtual reality accessible. Immediately after this symposium, we launched the XR Access Initiative. The goal of the initiative was to fulfill that agenda. So the goal was to make sure that augmented and virtual reality technologies are accessible, are board accessible. So accessible from inside the box. So you can go to the store if you have a disability, buy a device, or order it on Amazon, more accurately, buy a device, download, whatever application it is that you want to download, and it will be accessible. You don't need to make any customizations or buy any additional specialized hardware or software. That's how XR Access was born. And since 2019, we have done a lot of things. And mostly our activities fall into a few categories. So number one, we work on producing XR accessibility research. And I'll give you a taste of that research very soon. So basically, it's research to figure out how exactly augmented and virtual reality technologies can be accessible. There are many, many open questions. It's actually a fascinating area because it's just a completely different computing paradigm than what we currently have with screen-based technologies like computers and laptop and desktop computers and mobile devices. So there's just a lot of unknowns about how to make it accessible, what people with disabilities needs are, and that's where the research comes in. We also do a lot of community events. So we bring communities together. And primarily, when I say community, I'm talking about bringing together people from academia, from industry, from the nonprofit and advocacy world that we originally brought together from the symposium. So we bring together people for our annual symposiums. Those are our flagship events every summer. We also have seminars every month or other month. And we have some other activities, on ad hoc activities for people to come together. We also develop resources. So if you go to our website, there are a lot of resources, a good number of which we have contributed to ourselves. And these resources are designed for people who want to learn more about accessible augmented and virtual reality. So whether you're a student or whether you're a practitioner, we put together guides and instructions on that draw on what we currently know, so the current state of the art in how to make these technologies accessible. And then finally, we also focus on education. For example, we had a research experience for undergraduates program for 3 years. We hosted it in collaboration with Steve Feiner and Brian Smith at Columbia University. We just completed our 3rd year. So the funding was only awarded for 3 years, but we have many more educational activities planned to come. So that's something we're very interested in, actually educating the next generation of leaders in technology so that they are trained in and aware of XR accessibility. Now I will shift over to an example of the kind of research that we do. This is a project that we call VR Guide. And the goal here was to make social virtual reality accessible. So I'm presenting this to you because I think it's a really cool project, and I hope that you will see how fun and exciting this space of XR accessibility really is. So this project was led by 2 of my PhD students, Jasmine Collins and Crescentia Jung, in collaboration with Yeonju.
Slide 10. VR Guide, making social VR accessible.
I forget Yeonju's last name.
Danielle Monter Headship, disabled.
Yanju Zhang and Danielle Montour, and also
Slide 10. VR guide. Making social Stevenson
Andrea
1.
Stevenson 1, who you may have heard about. She does a lot of VR research. She's a faculty collaborator who I collaborate with a lot in this space. So like I said, in VR Guide, we were focused here on making social virtual reality accessible to people who are blind or have low vision. And there actually have been prior efforts on making virtual reality accessible to people who are blind or low vision. We're not the first. And there have actually been efforts dating back to like 20 years ago. So this is not a completely new area. And the main approach that people have taken is essentially to add sounds to everything, to sonify everything. So to add sounds to objects in the scene and to actions in the scene. So here's the video, and this is why I wanted the sound to come through. So you can hear that the fountain is emitting a sound, so you can hear the trickling water. And there's also the sound of footsteps as the user is stepping closer. So let's see that again. So it's faint. I'm not sure if you can hear it, but you hear the little step, step, step. So that was the approach. If a bird is flying across the sky, you'll hear a chirp, 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 chirp. And this is spatialized, so the user who can't see can be aware that there is a bird and where the bird is. But what about social VR? Today, there are many social VR platforms like VR Chat. Are people familiar with social VR?
Yeah.
Yeah, good. So these are platforms designed for socializing or, for various purposes, whether it's for work purposes or just for fun. People can come together and join a virtual environment and talk to one another, interact in different ways. And, there's a variety of different environments that you can join on different platforms. And it's really cool. If you guys haven't tried it, then I highly recommend giving it a try. It's quite an experience. So with social VR, these environments, compared to the one I showed you in the previous slide, they're much more complex. First of all, you've got many different possible environments that the user can step into on these platforms. You've got many users who are moving around. Things are changing dynamically, right? It's unpredictable. This isn't a game where the programmer knows exactly what's going to happen when. And there are many, many objects that are also being manipulated in unpredictable ways. So if we were to sonify all objects and all actions, we would just get a flood of sound, and it would be impossible for the user to figure out what the heck is going on. In addition to that, it would be extremely disruptive, and you wouldn't be able to actually talk to people. So the whole point of being in the social VR space is to communicate with other people. But if you're trying to listen to what's going on around you, then that would make socializing very, very difficult. So the approach that we saw in prior work, where we just sonify everything, is clearly not going to work for these more complex and unpredictable environments. What do we do then? Well, the real world is also complex and unpredictable. So let's take some inspiration from the real world. In the real world, there's an accessibility technique called sighted guide. And this is actually very simple. So this is when a person who is blind or low vision, they simply touch the back of a sighted person's elbow. So if I was doing sighted guide with someone else, I would just touch the back of their elbow, and then I could walk with them. So you get a lot of feedback from that person by simply touching their elbow. You can sense their movements very well. And this way you can walk with them through complex environments. And of course, you can also talk to the person. So you can just have natural conversation to get information about what's happening around you, where you are, and so on and so forth. You can just be human together. And And by the way, touching someone in the back of their elbow is this is much more helpful than like holding someone's hand for various reasons. Holding someone's hand, first of all, is much more intimate. You don't necessarily want to do that with just any random person. And if you think about walking and moving your hand, you can move your hand in all kinds of directions. And, you could keep your hand still while walking up and down a few stairs. So you really don't get that much information about what the person is doing, how they are walking or maneuvering from holding someone's hand. So this is why we use the back of the elbow in sighted guide. Sighted guide is used in the real world. Then the question became, can we adapt this to virtual reality? And that's where VR guide, the concept of VR guide came in. So we asked 2 research questions to guide the project. So the first research question was about people's needs. So what accessibility needs can a guide, and I have my Zoom window in the way. Let me get rid of this thing.
Zoom floating video window. Zoom floating video window. Command. Slide 14. Research questions. Disabled. Slide 14. Research questions. Disabled. Slide 14. Research questions. Slide 14. Research questions. Disabled. Slide 14. Zoom floating video. Slide 14. Zoom floating video. Slide 14. Research questions. Disabled. Zoom floating video window. Zoom share toolbar window. More. Menu item. Slide 14. Research questions. Disabled.
Sorry, give me a minute.
Zoom floating video. Slide 14. Research question. Command. Zoom share toolbar window. Zoom floating video window. Slide 14. Research questions. Disabled. Zoom floating video window. Slide more. Menu item. Slide 14. Research questions. Disabled. Zoom floating video window. Zoom share toolbar window. Slide 14. Research questions. Disabled. Slide 14. Research questions. Disabled. Zoom floating video window.
Okay, there we go.
Command.
Sometimes
Disabled.
it gets buggy and the cursor disappears on me. Okay. Okay, so first research questions. What accessibility needs can a guide address for blind people, for blind and low vision people in VR? And then the second research question is about design approaches. So in other words, how can you design, possible ways to design the guide? So what design approaches for a guide can address
Slide 14.
those
Research questions.
needs?
Disabled. Slide 16. Shared movement. Disabled.
So we developed a framework for sighted guide in virtual reality. In other words, we adapted the sighted guide technique to a virtual setting. And we call this feature shared movement. So the way this worked is that if we're in a social virtual environment, then there are multiple users who can enter that space. And we have one user who can serve as a guide and the other user who can use that guide. So the blind or low vision user, to use the guide, can simply get close to the guide. And when they are within a certain radius of the guide, they can grab onto the guide using the trigger on the controller. And then as long as they continue grabbing, they will move along with the guide. So we're simulating holding on to the guide's elbow and walking with them. So as long as the user is holding on, is still grabbing the guide, then the user does not move independently. The guide can walk or teleport, and the user will automatically walk or teleport with them. This is the shared movement feature that simulates sighted guide in VR. And then when the user wants to stop or get out of this shared movement, then all they need to do is stop grabbing or release the trigger button on the controller, and then they can continue moving around independently. And all throughout this time, they can speak to the guide can speak to them, all of the usual things that you can do in a social VR platform. So we did a study with this shared movement feature, this VR guide infrastructure. We recruited 16 participants to answer our research questions. And these 16 participants were all blind or had low vision. They came over to our lab. They tried out 3 different environments like the one you see here. So the environments were designed to look like municipal parks. In each environment, they were joined by a guide, and the guide was embodied by one of the researchers on the team. So they could use the guide to explore the environment. We gave them some simple tasks to find various things, various objects in the environment. We asked them to describe the environments when they were done. And we also observed and recorded all of their interactions with the guide. Then we analyzed all this data, and I'll present some of what we found now. But for the complete findings, you're welcome to check out our paper. So here's a sample interaction.
All right, can we just continue on a path? Like, is there a path that goes all the way around it?
Yeah, it looks like there's a path right behind us that goes to another area of the park.
Okay, let's turn around and do that. I'm gonna grab on again.
All right, so this is from the guide's perspective. This was recorded from the guide headset. So you hear the participant asking the guide a question to help her get oriented. And then once she figures out where she wants to go, then she says, okay, great, I'll grab on. She says, let's do that, as in let's go there, and I'll grab on. She's going to engage the shared movement feature and have the guide take her to where she wants to go. So let's just watch that again.
All right, can we just continue on a path? Like, is there a path that goes all the way around it?
Yeah, it looks like there's a path right behind us that goes to another area of the park.
Okay, let's turn around and do that. I'm gonna grab on again.
Yeah, so what we found was that participants all worked with the guide pretty well. They were able to navigate the environments along with the guide. They were able to pick up at least one of the objects that we asked them to pick up. Most of them were able to pick up a lot more than that. And they were able to learn about the environments such that they described them back to us in quite a bit of detail, and that all the detail they provided was accurate.
Slide 18, interactions with the guide, disabled.
So we categorized all of the interactions with the guide, all of the verbal interactions with the guide. What we found is that the interactions fell into 3 categories. So on the one hand, we had participants request information about the environment from the guide. So for example, what's up ahead? Is that a waterfall? Can you tell me about the park? All kinds of questions like that, requesting information. This was the most frequent category of interactions. The second most frequent was actually verifications. So verifying what the participant already knew. Especially the low vision participants. They really liked having the guide to just verify what they perceived themselves. For example, they would perceive that there was a path ahead to a gazebo, so they asked the guide, this path leads to a gazebo, is that right? And the guide would say, yeah, that's right. This was actually a very important part of the interaction for many of the participants. And then thirdly, the third category and the least frequent was requests for actions. Of course, one of the actions that the guide could do was to take the participant places, this navigation support that the guide provided, which was originally the primary support that we were thinking of, that we had in mind. But interestingly, we also found that participants wanted the guide to do other things for them. They wanted the guide to pick up objects for them, or to interact with the environment for them. And in the interviews following the tasks, they had suggestions for ways that the guide could alter the environment to make it more accessible in ways that we hadn't implemented yet. So that was pretty interesting. We observed that participants were conceiving of the guide in more or less two distinct ways. And this was interesting. We found that a good number of the participants seemed to conceive of the guide as a tool. They called the guide. They were very direct in their requests. They didn't have any extra small talk or conversation. They really treated the guide like a tool. And then on the other hand, there was a set of participants that treated the guide like a companion. They asked the guide for her name, and they engaged in some small talk. We even had one participant who wanted to dance with the guide.
Oh, I want to dance. Hey.
So you can see the end that the guide kind of started to dance a bit. You can see the camera bobbing up and down. So this is very fun. It always brings a smile to my face. There was a lot of discussion after the guidance experience about what participants wanted the guide to look like. This is right here what the guide did look like. So we chose an avatar that kind of looked like the researchers on the team, a young woman who had dark hair, in this case, Asian features, who was dressed in a casual style. So representative of what the students on the team looked like. And participants said that this would be fine in certain situations, and they wanted the guide to conform to the dress code that was expected in the virtual environment. So for example, if they were in a virtual environment that was work-related, they wanted the guide to appear more professional. But overall, they were pretty satisfied with this appearance. For more casual environments, though, they wanted to get a bit more creative. They felt that there was some room to get more creative, and they suggested that maybe the guide doesn't need to be another human, but maybe the guide could take on a different form. Four participants, completely independently of one another, suggested that the guide could be a bird perched on their shoulder. So that was kind of cool. So in this case, it would still be another human, but this human would be represented by a bird. And other participants had some other ideas, other types of creatures, maybe a white cane. Participant wanted the guide to look like their guide dog. So they felt that in these more casual settings, there was some room for creativity here that in the physical world you are unable to have. So that brings us to next steps. Overall, I think this is a very exciting line of work, and we are continuing to work on it for sure. I'm looking forward to making this a reality and to actually supporting guidance in real existing social virtual reality platforms. I think that there should be some exploration of different ways of doing this. Do we want the guides to be paid volunteers? Do we want them to be friends? If they are friends or paid volunteers, what kind of training should they get? How do we maintain some level of quality? What does quality even mean in this context? So I think there's all kinds of interesting things to do here. And then, of course, I'm sure you're all thinking already, well, what if the guide can be AI and not human? And yes, we are currently working on this. And it is a very fun project to be working on, especially at this time when you have such powerful AI tools. So we'll see how an AI guide compares to a human guide in all of the different aspects that I've discussed so far. We're actively working on that. that was just one project that is representative of the kind of research that we do as part of XR Access. But there are many other opportunities, and it's not just research for my lab to be doing, but everyone should join in who is interested. And there are all kinds of different needs that people have, different disabilities. So just to name a few categories that XR Access has been more involved with, we have people with visual impairments, vision disabilities, blind and low vision. We have people with hearing disabilities. XR Access has been involved in a lot of work on standardizing captions in VR. People with motor and mobility disabilities who might have difficulty using the controller or moving in a standard way. And of course, people with cognitive disabilities. Right now, we're also doing a lot of work with people with ADHD and autism in VR, trying to understand what their needs are. When I gave this talk at IEEE VR, so someone said to me, "What about people with speech disabilities?" And yes, there are there's wonderful diversity of human ability, and so lots of different people and needs to consider. So this is by no means an exhaustive list. So if you are interested in getting involved, this is the process that we promote at XR Access. This is the community-based research cycle. If you are familiar with the UX life cycle, this is similar, but a little bit different. And the idea here is that you start out.
Slide 25, community-based research cycle, disabled.
Is that you start out by connecting with your community. So there's a lot of informal work that goes into doing good research. A lot of work that you do up front, getting to know people, making friends, doing activities, talking to people. It's that humanity that is not necessarily going to end up in your final paper, but it is a fundamental aspect of good research. After you do that work, to really get to know the population that you are interested in working with, then you can move on to the analysis phase, and this is a more formal investigation of user needs. So here's where we start getting closer to the UX lifecycle. This is where you can do more formal studies to understand people's needs and abilities. Then you can move on to design and prototype, which really goes together. Every time we design something, we are also prototyping it to represent our design. So you should be developing prototypes at increasing levels of fidelity. And all along, you want to be evaluating them. And in your evaluations, you want to bring in the people who you've established connections with to do both informal and more formal evaluations to assess whether you've met your goals, your design goals. While you're doing this, you should absolutely get involved in XR Access. And everybody should get involved in XR Access. So we have quite a few events coming up. We have the XR Access Symposium. So actually, this slide is a little out of date, but we already had our call for papers. Soon we'll be announcing who has been accepted. And we just opened, the latest news on this is that just today we opened registration for the XR Access Symposium. It's happening June 6th and 7th in New York City on our campus. So it's every year we get bigger and better. So this is going to be a really great event. We had over 50 submissions for talks, posters, and demos, and we have a great variety. So we haven't publicized this yet, so I'm not going to say very much. I'm just going to say that we have some really awesome talks and a really, really nice variety, both from academia and from industry. So I'm super excited about it. We're going to have, in addition to talks, it's not just going to be talk after talk after talk like an academic conference. We're also going to do some fun things. We'll have some breakouts. We'll have a poster session. it's going to be good times. And the registration costs for students are really low. And if you even want those waived, then you can volunteer to be a student volunteer. You can also apply for a scholarship. So we will have some amount of funding that we can provide. Hopefully we'll get more. I'm working on that right now, but definitely apply for a scholarship if you need the funding. And yeah, it's gonna be great. So I highly recommend everyone sign up. Join our mailing list. Join our research network first, and also join our mailing list. But join our research network if you are interested in research in this area. So this is for people who are actively doing research in the area. We're trying to establish a tight-knit community of researchers in XR accessibility. We all have our larger communities that we're associated with, whether it's like the accessibility community, like I'm part of the larger assets community. There are people who are part of the VR, who affiliate more with the VR community, but we want to create a really close-knit group of people who are in this intersection of XR and accessibility. So we're gonna be able to share the latest research with one another, look for collaboration opportunities, and do all the things that academics do. So definitely sign up for that if you're actively doing research in this area. And you can also join in any of our remote events. So even if you can't make it to the symposium, and if you can, you're welcome to join our remote events. So we do seminars every month or so. We have one coming up in May. I believe it's May. Yes, it's May 2nd. Folks from Microsoft Research are going to be presenting about a project that aims to make VR accessible to people with visual disabilities. So definitely sign up for that. You do need to register to get the Zoom link. So it's on our website. You can also email info@xraccess.org if you have any questions. And sign up for our mailing list, of course, to get updates on all this stuff. We really don't spam you. We think hard about what we put in our mailing list. So we only send them out once a month, and they really do have relevant information. So with that, I want to conclude just to say my thanks. Dylan Fox is the person who is basically running XR Access. He's the director of operations. He also helped with this presentation. So everything you see happening at XR Access is really like 95% Dylan. He's amazing. I want to thank Jasmine Collins and Crescentia Jung, who are my 2 PhD students. So I spoke about their work, the VR guide. Andrea Stevenson, one, like I said, she's the faculty member who I collaborate with a lot on a lot of this research, and she's fantastic. And Greg Welch he's in the VR space. He's been extremely supportive. He's the one who also invited me to give the keynote. So thanks to him, this presentation was created. And yes, and thank you to you all also for being here and for inviting me to speak. So with that, I'm happy to take questions.
All right, thank you. So let's open the K1 questions.
Slide 31. Question. Zoom share toolbar window. Move to bottom button.
Matthew?
Zoom share toolbar window. Start video button.
Thanks for the talk. So I was curious. So in the one video you played where the person was being led around like the path in that small park, there was like a buzzing sound at the end of the video. And so I know, at least it's from the paper we read in the workout we looked at here, that you looked at kind of most of the auditory ways to help people with visual disabilities. I was wondering if you had done any work looking at either haptic feedback or worked for people with auditory disabilities.
Right. So the question is, have I done any work looking at haptic feedback? Yeah. So did you have 2 questions? So a separate question, yeah, haptic feedback, and also for hearing disabilities?
Or looked at applying any technologies for people with visual disabilities, auditory disabilities. So hearing problems as opposed to visual.
I haven't done any work on VR and hearing disabilities. There has been some good work done by other labs. In terms of using haptics, we definitely have been looking at using haptics to support people with visual disabilities. I think that there's a lot of potential for haptics. The problem is that right now, the haptics that you have, like the design space for haptics that's available to you, given today's technology, is very limited, right? So what I mean by that is that so we use mainstream devices because we want to make mainstream devices accessible. And right now, whatever haptics you have is basically some vibrations on the controllers. So, you know, there's a whole lot of other haptic feedback that you could potentially be giving. And I know that there's a lot of work on new haptic devices for VR kind of in the research pipeline. But in terms of what's out there and what we've been working with, there isn't much to work with. So what we have done is looked at using haptic in addition to audio. And I'll give you one example. So we did this when we wanted to signify that somebody was looking at you. So if I was in a social virtual space, and like, let's say we were all together in a social virtual space, and somebody was looking at me, like trying to get my attention, then I would feel a vibration on the controller. And we used audio for various other social cues to represent other social cues. So you can read about that. There was actually a poster paper that we published at ISMAR about that. Can't remember what the title is exactly, but it's something to do with gaze, G-A-Z-E, representing gaze. It's from ISMAR 2022. No, 2023, this last year.
Thanks.
Okay, now we have a question from Professor Michael Scott.
I had a very similar question to the one before. It just seemed to me that one of the most important things that would be missing for a visually impaired person in VR was a good sense of movement. And if you're working with a guide and you latch on to the guide at the elbow, in the real world, you're getting tactical feedback on the acceleration and deceleration of the guide, basically, a sense that you're moving through the space in addition to the proprioception. And in the virtual environment, if you latch on, you may get an auditory cue that you're latched on, but then you have no sense of whether you're going forward or backward or left or right. And it just seemed like some sort of tactile feedback, even if it wasn't particularly representative of the tactile feedback in the real world, would still be useful. You'd have a sense that you were moving. You know, I could easily imagine doing this in the really sophisticated case if you have a tilt platform, but a controller that vibrates on 4 sides might be able to do something that would be useful.
Yeah, I agree with you 100%. I think that would be a really interesting thing to look into. We do give vibration. We do give a vibration indication when you are latched on. So but it's just, you know, it's just vibrate on when you're latched on and then turns off when you're not. So it's not doing what you're saying. But I agree with you. There's definitely a lot more to explore there. And what you're saying is also a general problem with VR, right? Even when you do have the visual feedback of moving forward or turning left, there's still a lot that you're missing there because you don't have the feel of it.
Of course, but
Yeah.
at least you have the visual cue.
Right, right.
Thank you for your talk. This is Daniel. It was very entertaining, and a lot of the topics you covered somewhat reminded me of the more general effort for accessibility in video games. So I have 2 questions that kind of come from that perspective. The first one is that there's a lot of controllers on the hardware side, which are specifically designed for people with different disabilities. And there's a lot of success in them when they come from first party, like, for example, coming directly from Microsoft. I really appreciate the effort for you to take these ideas beyond academia by targeting actually commercially available devices. But considering there's already a practice of buying a separate peripheral for people with certain disabilities in other areas like video games, do you think that that's also feasible, in which you can have a commercially successful device like an Oculus Quest, for example, but you can buy an additional peripheral which can provide you with some extra functionality and accessibility, kind of like the vibration accessibility, which may be limited in the commercial controllers, but can be expanded to have a little bit more functionality in a third-party solution.
Yeah, totally. I think there's a lot of potential there. I think at the very basic level, it should be like, if I want to use an Oculus or a Meta Quest, I should be able to just buy a Meta Quest and use it. But I agree that, you know, if I wanted to buy an extra controller and get even more awesome features, like that should also be a possibility. So yeah, there's a lot of interesting questions there too. How can you leverage those other devices?
Yeah, that makes a lot of sense. On that topic, the second question I had is, I wonder where you think this responsibility falls regarding the chain from the hardware to software to developers, of where these features have to be implemented. And again, from what I'm a little more familiar with, which is from game development, I think one of the things that have been most successful is integrating some of the software features within the commercial game development engines like Unity and Xreal, because then the barrier for a developer to add that functionality is significantly lower. So do you think that's similar for this application, or do you think it's a little bit different and it really should fall somewhere differently, like in the hardware or somewhere else in the process chain?
I think that, so okay, it's hard to say whether in terms of hardware versus software, it's hard to say, because there's so many different needs and different different ways that you should make something accessible, right? For example, people who wear cochlear implants have a really difficult time wearing head-mounted displays just because they don't fit quite right, because the cochlear implant gets in the way. So that's obviously a hardware issue. Yeah. Right? No amount of software is really going to fix that. But what you said about tools, better tools to support accessibility, I mean, that's absolutely right. There really have to be better tools. I mean, it's just such a complex question. There's definitely a need for tools that help you build in accessibility, or to the extent, to whatever extent possible, that already build it in. And right now, I mean, there really isn't. There should also be tools that are accessible in themselves, because then we could get more people, you know, from a more diverse set of abilities actually creating the technologies. And I think eventually that is what we really need to make the technologies accessible. In terms of where does the responsibility lie? I don't know. That's such a complicated question. I did do a study a few years ago that looked at how companies actually produce accessible products, in particular large tech companies. So we interviewed accessibility practitioners at large tech companies, and we talked to them about their jobs, like how they work. And I mean, they really, the way these companies typically work is that they'll have an accessibility team who are the experts, and they'll try to raise awareness across the organization and do some education work. For example, like new hire orientations. So it's something that everybody really has to be aware of and thinking about at all levels. And then they also offer like office hours and ways to connect with the accessibility team to help all the other teams actually make sure that they are making whatever it is that they're working on, whatever aspect of the product, accessible. So it's kind of like an overall effort. It's not isolated to any one particular part of a product.
That makes sense. Thank you.
Professor Zimbai.
Hi, Shiri. Thanks for the great talk. I really like the project, the navigation project, because it's kind of introducing a new dimension in the VR navigation, which is the social aspect, which we don't usually think that way. But I think through the research with people who are blind and low vision, it's really adding a new way of thinking, like how we can navigate in a space, adding the social aspect. I do have like a question, like I've been wondering that I think this great experience that people kind of bringing their life experience of another person, helping them to navigate in a physical space, in the social, a physical space, in the virtual space. I'm just curious if your team have thought about some like some non-traditional navigation method that is not possible in real life. Like for example, there's this like teleport, for example, that does not require people to have this, very accurate paths to go from A to B. So that could be one example, like instead of, okay, let's walk there. We can just, you find a spot and then we will teleport there. But I'm just thinking there seems some really interesting opportunities to explore more than that, like something that might be inspired from this particular user population, but might be beneficial for other users as well.
Yeah, I completely agree with you. I think that one of the fun things about this is that you're not limited to the physical constraints of the real world. And one thing that we did that I didn't talk about was we implemented a flying function for the guide. So the guide could fly, and in addition to walk and teleport. And participants use this in two ways. So they had the guide fly up and get like a bird's eye view and then answer questions about the environment, or they did shared movement with the guide and flew up with the guide. But overall they didn't like it. It was interesting. So I think that it's maybe there was a learning curve problem, because it's just VR is a completely different paradigm.
Yeah.
And it's hard enough. And all of the participants, they're new to VR, right? Because again, the mainstream technologies are not accessible to them. So some of them have participated in user studies involving VR. So they've had some very minimal experience, but they still haven't had a lot. And so I think that just figuring out what was going on with kind of navigating in the more traditional ways was already a lot. And the flying, I think, might have been a little bit confusing, or maybe they just couldn't quite figure out what to do with it. Like what was it good for?
Right. I guess there's a really big gap from following the existing paths in the environment or some predefined locations to suddenly it's phrased out like it's so open-ended, like might just easily feel disoriented, I guess.
Yeah.
But yeah, super interesting. Looking forward to learning more about, all the new ideas and inspiration to not only, enrich our understanding of how to customize the VR environment, but maybe some new exciting directions for navigation.
Yeah. Thank you.
Thank you.
Richard Chuang.
Yep. Hello. Hi, Shiri. My name is Richard Chong, and I actually had the chance to attend last year's XR Access Symposium. It was a great experience, and I'm really excited about what XR Access means for the direction of the field. And that leads me to kind of want to ask, given the increasing importance of accessibility in XR technologies, how do you envision how others can, continue promoting, creating new platforms to facilitate that collaboration and knowledge sharing among, researchers, industry professionals, or just advocates in general, to further expand accessibility in all sorts of fields, but especially XR technologies?
So you're asking how to promote accessibility?
Yeah. How can we continue that wave of creating these platforms that just continue pushing the field forward in this great direction.
Yeah. Well, I think that so being an advocate is extremely important. Let me just say that before I get into the how. What we found in the research that we did with technology companies is that a lot of the accessibility work is done by advocates, which they call champions, who they call champions. Even in large companies, like even at Twitter, they didn't have at some point, I think they do now, or maybe, I don't know, they laid them off at some point. So I don't know what's going on there now, but at some point they didn't even have an accessibility team. They just had accessibility champions. So there is a lot that gets done by just people who take it on themselves. So it can make a huge difference across an organization. So first you should know that and be empowered by that knowledge. And in terms of how, I think that just showing that there's a need to learn about it, showing that you want to learn about it, ask if there's a course about it, just the squeaky wheel gets the grease, or whatever the expression is, right? You want to make yourself heard. If you go on job interviews, ask if they consider accessibility when you're working. Ask if the team has considered accessibility. Make a connection with the accessibility team if the company has one. If not, then you can start designating yourself the accessibility champion, and establish yourself as a point person for other teams to come to if they have questions. Because what we find is that a lot of people care. People care, generally speaking, but they don't know what to do about it. So, if we just have a few people that take ownership and take the initiative, then that can make all the difference.
Nice. Yeah, thank you so much. And I love that title, champion.
Mm-hmm.
Anyone else? We have time for really short questions. Okay, so I'd like to say thank you to Professor Shiri Azenkot, and if anyone want to follow her work, it is on the chat. And also, I'd like to tell everybody to check the Voice XR speaker series from the previous series and the next ones also. Thank you.
All right. Thank you so much, Shiri.
All right. Thank you, everyone. Bye.
All right. Bye-bye.